Hello everyone. This is a check for the voice. I want someone to just volunteer me and just confirm me whether it is audible. Someone just confirm me whether my voice is audible. Hello, this is a mic check. Can someone just confirm me whether the voice is audible, please? I'm just checking for my voice and my screen. I want to know whether my screen is visible and my voice is audible. Okay, I won't even know my audible. Okay, so thank you so much for your response. I can see people messaging me that you can hear me. Thank you so much. So very good evening everyone. Welcome to the LabVIEW online course. This is a 5 days course in which this is going to be the first day of this training. So first of all, I want to all wish you happy and a safe quarantine. Stay home, stay safe. So let me give a brief introduction about this session, what we are planning to do. So we are starting this 5 days training continuously starting from today, directly 5 days into the this week. So this training starts from the beginner level so that any new person for LabVIEW can be able to grasp it from the day one. But going deep into the days, second, third, 4 and 5, we'll get into the important topics, important toolkits, and we'll be trying to reach what are the use cases of LabVIEW and how it's being used in industry, automation, IoT. We'll try to touch all the parts as much as possible. We have 5 hours left to us. So my name is Vasant Kumar and I'm a senior application engineer from VI Solutions. So today's topic is going to be about the system design using graphical programming language, and it is nothing but our LabVIEW, right? Great. So moving into the topic, today's agenda is going to be split into two divisions, section 1 and section 2. So today we'll be seeing LabVIEW, what is LabVIEW, the environment of LabVIEW, the components of the application of LabVIEW, and programming tools of LabVIEW application in the section 1. Moving further, in the section 2, we'll be seeing how to create a LabVIEW application. We'll be trying to design some simple applications. And moving further, yes, we'll be seeing what is the loop concepts in LabVIEW and related functions that can be allowing us to use loops in full-fledged. And before that, I saw some queries in the chat window. You people can feel free to write your comments and your questions and queries in your comment windows, where I'll be addressing them at the end of the session, not in between. I don't want to interrupt the flow because it's just a 1 hour session. I want to finish the flow, and you can feel free to write your comments and you can feel free to ask your queries down in the comments section. So I'll be addressing them after the 1 hour session which is being held now. And moreover, this video will be available in our YouTube channel offline also. So in the future, you people can come back and you can watch this video in live. In offline. Yeah, thank you so much. So I'll just get started. So LabVIEW basically stands for Laboratory Virtual Instrumentation Engineering Workbench. So I'm not sure how many people attending here are aware of LabVIEW, but still I'm planning to start from the scratch about LabVIEW. See, most of the people I came to know about, the beginners always think LabVIEW is a simulation tool, but I want to make it clear about LabVIEW and its use cases first of all. So LabVIEW basically is a toolkit that can interface with hardwares. Usually LabVIEW has all toolkits, APIs, functions that can be programmed in real time in desktop instruments and even in FPGAs, right? So if you see the screen, you'll be able to see that it can be interfaced with FPGA. At the bottom, you'll be able to see the FPGA icons, right? So, and also you can see that it can be dumped into the application, the ICs, so that you can make standalone applications. you can also use LabVIEW in simulation mode. That's for sure. It is not the actual use case of LabVIEW. LabVIEW is meant to be interfaced with hardwares. Right? So you people, if you have worked on LabVIEW before, right? So you can also come up to me and give your suggestions in the future, so that what kind of videos we can make related to the hardware interface also. We'll be happy to do it if people who just watch our channel wants more information regarding that. Fine. So just moving further, I'm just getting deep into section 1 right now, understanding the LabVIEW environment. So before understanding the LabVIEW environment, I also want you to understand what is a virtual instrument. Basically, we people use LabVIEW in all domains, but the dominant domain which been using LabVIEW for many years now is automation field, where we bring both hardware and software together. I know many people believe that LabVIEW is a software and how this is going to be useful in hardware, but exactly speaking, LabVIEW is a tool that is being used to configure, control, acquire, log, and all the informations with the hardware. So virtual instrument is nothing but bringing your hardware and software together. It's like kind of integrating your hardware and software together. So what we'll be doing is we'll be writing a program in LabVIEW which is a software oriented, where we'll be interfacing the LabVIEW with the hardware, and which will be in fact will be connected to sensors, where we'll be acquiring, and connected to the actuators, so we'll be controlling items. So ultimately our aim is to design a IoT based automation system. That's the ultimate goal, what we are actually looking out for this 5-day stretch. And moving further, we can also go beyond 5 days, depending upon the feedback what we get from the people who mentioned in the comments. So feel free to tell what is your need in the comment section. So we'll be trying to look into it, each and every comments, and try to respond accordingly. Yeah, fine. And the LabVIEW program, the working screen, the place where we design a LabVIEW program, is basically called as a virtual instrument. This file, basically the LabVIEW program file, will have an extension .vi, whatever name you want to save it. .vi is exactly like your C program where you use .c, or C++ you use .cpp, or a MATLAB use .m. This is more similar to that. So we'll be addressing a LabVIEW files with the extension .vi. Right? So we call the LabVIEW working screen or the programming window as a VI from now, right? So, and moreover, if anybody feels like you want to have a hands-on session, finishing this 1 hour session, we'll be trying to paste the link to download the LabVIEW software, maybe the recent software or the same version which I've been using, so that it's more comfortable for you to understand what I'm basically doing. So I'll just try to send the address to, the link to you to download the LabVIEW, so that from tomorrow maybe you people can have a hands-on and try to do the same thing what I'm trying to do. But today you need a good look into LabVIEW's environment, which I'm going to directly dive into it. Right? So LabVIEW VI. What is a VI? VI is nothing but the workspace. As I told in the previous slide, the workspace in LabVIEW is called as a virtual instrument. In other words, we call it as VI. So a VI in LabVIEW has 2 windows, namely a front panel and a block diagram. So you can see here, I've clearly mentioned it has 2 components, front panel and a block diagram. A front panel is a place that consists of all your inputs and outputs, which is nothing but the more close to the UI screen. Right? So it's like a UI screen where the user can have his inputs and outputs on the front panel. And going beyond, we also have a block diagram screen where you have the actual program where you wire all the code graphically. So in other words, this block diagram program is also called as a G code. G code stands for graphical code, right? So this is a sample example of how a front panel items look like and how a block diagram items look like. So if you see the front panel items, it's more like a display inputs and output items, where you can see there's a switch where people can switch it, like whether he wants a Celsius or a Fahrenheit. You can see there is an output being displayed in a thermometer, and also there is a display being shown here. So this is a window where you can see the data as an input and output. You can fetch the data from here, and you can also pass your inputs into this. And this guy is a more important one. The block diagram is a more important guy in this entire scenario, where he has a real programming where the ultimate code lies here, right? So I'll try to show a depth example of a window of a front panel. So this is what you're seeing is a front panel window. This is how a front panel window in LabVIEW looks like. Anyway, moving inside, I'm just going to show a real-time demo of LabVIEW, how to use it. If you have LabVIEW parallelly, you can try using it in a hands-on. If not, we'll be sharing the link today. You can download it and install the basic version of LabVIEW. So see, this is a front panel which has all the UIs. When I say UIs, it's nothing but your user interface. When I talk about user interface, it's very simple. It is nothing but your inputs and outputs. For example, let me talk about ATM machine. If you talk about ATM machine, you can see it has a front panel where the user comes and try to feed his input and tries to see what is the output or the status of your transaction. Behind it, there is an application running, right? Behind this application running, which is more similar to your block diagram, right? So you can see it says it is a user interface window, and this is a front panel, which panel toolbar where you can customize all your items, like whatever items you have on the window, you can customize it using this toolbar. Fine. Moving into block diagram, this is how a block diagram window looks like. Fine. So a block diagram consists of a graphical source code. This is going to be the source code which is actually allowing your front panel to get updated. So when I see into the block diagram, you can see all the calculations coming into picture, logical items coming into picture, my algorithms coming into picture, my complete code lies into my block diagram, right? So this is the application development window where you design your application. Fine. And moving further, I want one more thing to be told to you before getting into a demo session. Directly after this, I want to move into a demo session. There's one more thing I want you to make it clear. There's something called as controls and functions palette. I repeat, there is something called as controls and functions palette available on front panel and block diagram. Your controls palette is available on the front panel. Can you see this control in the leftmost corner of my screen? Right? It is a controls window. It is available on the front panel. Likewise, you have a functions palette which is available on the block diagram. So why you use a controls palette, why you use a functions palette, I'm gonna explain it. So as I was showing you the front panel, I'm just going 2 slides before. As I was showing the front panel, there are some items available on the front panel. I want to customize the window of the front panel. I design the items on the front panel, right? So to do this, I try to use my controls palette to drag and drop my required items into my window. Hope I'm clear, right? So I'm just moving further for functions palette. Function palette is available on the block diagram. If I wish to create anything on the block diagram, if I wish to create something on the block diagram, I try to use my functions palette. So any items in the functions palette can be dragged and dropped, maybe picked and placed into my function, into my block diagram window so that you can start using it, right? Yes. So if you people can get into this, I want to quickly get into a demo to you people. So I'll just close this. I'll just close these windows. I'm launching my LabVIEW. So this window is LabVIEW getting started window. I repeat it. This window is basically called as a LabVIEW getting started window. So this window is a very important window because you have to start any of the application on LabVIEW with this window. So you are interested to create a application file, a exe file, an installer file, or maybe anything further like interfacing with the hardware, and IoT, anything you want to design, any application you want to design like robotics, still this window is going to be the base of anything, right? So I'm using 2018 version. This is not the recent version of LabVIEW being released. The officially released recent version is LabVIEW 2019. I have installed 2018 version. I'll allow you to get installed 2018 version, so it's going to be more compatible to you. So finishing this video by today, we'll be trying to give you the link of LabVIEW 2018 download in the same video. You can download it, and you people can find the link to to access the tomorrow's session in today's video, which means that tomorrow's videos link will be pasted in the comment section of today's video. You're getting it? So tomorrow we don't want to just try to reach you to send all the links, we'll do it, not a problem. But still, you can directly come to this video, and the comment section you'll be able to see the link for tomorrow's class. So tomorrow we'll be trying to paste it like 15 to 20 minutes well in advance of 6 o'clock, so that tomorrow 6 o'clock before we start, you can see the links being pasted here in the comment section. Okay, getting back to the demo part. So you'll be able to see File, Operate, Tool and Help in the menu bar. So what I'll do is I'll click on File, and you can see there is an option to select New VI. VI is nothing but the workspace in LabVIEW. As I told you, it's nothing but the workspace in LabVIEW. So there is an option to choose a new VI. I'm going to choose a new VI. So as soon as I choose a new VI, you can see there is an untitled two windows being opened. There are untitled two windows being opened. One is namely a front panel and one is namely a block diagram. As I told you, your VI consists of two components together, namely your front panel and your block diagram, right? So as I told you, visually you can see front panel looks a bit grayish with some grids, whereas the block diagram looks plain white. I'm right. So front panel is a window where you have all your inputs and outputs, right? And block diagram is a window that has all your functional part, application logical items will be available on your block diagram, right? So as I told you, you need to use a controls palette to insert any object inside a front panel. I repeat, you should use a controls palette to insert any object into your front panel. Likewise, you should use you should be using a functions palette to paste any item in the block diagram. I'm going to press Ctrl T, or I can just say window tile left and right, or you can see that there is a shortcut Ctrl T. I'm going to click this so you can see two windows, front panel and block diagram, tiled up side by side. So I'm going to start up with a basic example. So I want you to just look into the example. I'm going to show you how to drag and drop items on a front panel. Likewise, I'm going to show you how to drag and drop an item on the block diagram either. First, let me finish the front panel part. My idea of creating or showing a demo is, let me start a simple addition program. I'm going to show you how to design a simple addition program. Going further, I'm planning to do something little high-funder things. Even I have a plan to do a loop today. I'll move into those applications, but let me start with a simple addition program, right? So I'm planning to add two numbers together and display the output of the added inputs in my front panel. That's my ultimate idea I have. So to do this, I need two inputs and one output, right? I need two inputs. I need minimum of two inputs, actually speaking. Okay, so I need two inputs and one output. I'm going to show you how to create inputs and outputs on the front panel, but I'll make it clear your inputs and outputs are available only on the front panel because they are the UI items, the user interface items. So they are available on the front panel only. Coming back to your block diagram, all your applications like add operator or whatever maybe I'm going to use in the upcoming demo, they'll be available on the block diagram. Right? So I'm going to show you how to call an item into a front panel. Can you see my cursor with a plus symbol? Yes. I right click on any of the workspace, the gray space, in the front panel. I right click. You can see a controls palette popping up. I repeat it. I right click on the gray space. You can see the controls palette popping up. Same way, if I right click on the block diagram, you can see the functions palette popping up. You can never change it. They are customizedly set in such a way that always you get a controls palette on the front panel and functions palette on the block diagram, right? So right click. So if you see, my ultimate aim is to create two inputs and one output, and here comes a necessity to choose your data type, right? So I'm supposed to choose my data type. See, I personally want to show all the data types available here, but I don't think so I have much time. What I'm going to do is I'm going to take some examples of some data types whenever needed. I'm going to explain about that data type whenever needed. So I'm not going to explain all the data types here. So going further in the course of 5 days, I believe that you'll be available. You'll be accessing most of these data types. I'm planning a session in that way. So what I'll do is I'll go to numerics. Fine. So I repeat it. I'll right click on the front panel. Go to numeric. You can see the first item is numeric control and the second item is numeric indicator. As I told you, controls are nothing but your inputs and indicators are nothing but your indicators are nothing but your output, right? In LabVIEW we call controls and indicators, whereas in normal applications we call it as inputs and outputs, right? So your controls are nothing but your inputs and indicators are nothing but your output. Fine. You can also feel free to have any of the graphically represented inputs and outputs. So you can see there are a lot of graphically represented inputs and outputs, but right now I'm going to keep it simple. I'm going to use a normal display, normal digital display. So I'm going to drag and drop the item, right? And you can name them. This is a variable I'm being creating here. You can name them. I'm going to name it as input A, for example, right? So I've created one input, then I just go drag and drop one more control. I'm going to name it as input B. Fine. I can align them however I want it. I can resize them, like select them and use control and plus, it resize itself, right? I can place it the way I want because I want to customize it the way my customers want to see it, my user wants to see it, right? So then I'll right click once again, numeric, I go to numeric indicator. I want 2 inputs and 1 output, am I right? So 2 inputs are created and my job is to create an indicator right now, dragging and dropping this here. I'm going to name it as output. I'm sorry, output. Fine. So I'll even increase the size, right? So I've been creating 2 inputs and 1 output, which I said this is what is my need. I've done my necessity. So I have created 2 inputs and 1 output. So I was like very sure that I was not using my block diagram, but still you'll be able to see there are corresponding terminals being created on the block diagram. So whatever I try to create on the front panel, that will have a corresponding terminal on the block diagram, right? For input, for output, for both, right? You'll be seeing them, and very importantly, I'll try to zoom in. I'm trying to zoom in my block diagram. Whatever you're seeing now is a zoomed version of your block diagram. So you can see there are 2 inputs, namely input A, input B, and 1 output, and you can see the names mentioned as input and output because I customizedly made it as input A and input B. That's okay. But one thing is, you can see there is an arrow mark which is facing outward for inputs. In other ways, controls, you can see arrow mark facing outward in your inputs and arrow mark facing inward on your output, right? There's a major difference on your block diagram. You can see all your controls, any type or any data type of control will be having an arrow mark facing outward, and same as that your indicators, or in other ways your outputs, will have arrow facing inward. The reason is because this is the input terminal, kind of a source item, where you can see the data gets sourced here and passes out from here, these terminals, and you can use the center space and you can do some logics, manipulate the data, do some customized applications in this, data values, and you can update the indicator here. Fine. So how they work is, whatever number I feed here, for example, for demo purpose, I'll just make 10 here and 12 here for example. What happens is, as soon as I execute this application, this value of 10 moves to the corresponding terminal here, and the value of 10 starts passing out from here. Same as such, when I try to execute this application, the value of 12 from input B starts passing out from here, and I'll be trying to use an logics and try to do some manipulations to the value, and the output I'll try to update it to my output here, and the data which I update here will be visible here, right? So whatever I try to pass it on my input goes to the terminals on the block diagram. Whatever terminals on the block diagram is getting the data on the indicator will be updated on the front panel. As simple as that. So what I'll do is, my inputs and outputs are being created. Then what I need is, I'm supposed to create an operator, because my inputs and outputs are available. Now I'm supposed to operate it. So to do that, I come to my block diagram. Why now I come to the block diagram is, my inputs and outputs are actually available in the front panel, which I've actually completed it. Now coming to the block diagram, I right click on the block diagram. I have functions palette. I somewhere see on the second row, first column, I see numeric palette, right? I see a numeric palette which has all the functions which is more related to the numerical data. So I'll drag and drop it here, right? I'm dragging and dropping my add function, right? I want to add it, so I'm dragging and dropping this add. So just closely watch. excuse me, just closely watch. You can see my cursor looking like a plus mark, right? It looks like a plus mark. I move my terminal close to this one, the arrow marks, right? I'll move closely to this, click, drag a wire and click it like this. I repeat it. I go to this terminal, I touch this terminal. You can see it changes into a wire bundle. You can see it looks like a wire bundle. It's called a hotspot. That's a wiring tool in LabVIEW. So LabVIEW automatically changes its connector cursor, right? So I'll just come touch this. You can see there is a wire bundle visible. Click, drag, touch here. Same message from here to here, right? So you can see that whatever I try to pass here, the value 10 comes here and the value 12 comes here, and they get passed in the wires, get added, and the output will be updated on the output terminal here, and that will be visible here, right? So this is my code. It's done. I'm going to show you how to execute this application, right? So you can see here, you can see the untitled front panel name. That is a title bar. And then you have a menu bar, file, edit, view, and all those things are there. And then below to it, you can see the toolbar. The first item of the toolbar is nothing but your run. Run is nothing but it's the function that allows you to execute this application. And then you have run continuous. It's like, executing your code continuously. More similar to a loop, but there is a slight difference between a run continuous and a loop, which I'll be covering in the upcoming time. So then you have a abort. Abort is basically like killing a program which is being executed, and you can pause it whenever you want it. So these are the main four functions we'll be using. The same functions are available on the block diagram also, but there are some more different functions, like there are some highlights, and there are something like retain wire values, then step in, step out. We'll not get depth into that, but I'm going to show you how to execute this application. So what I'll do is I can set some value. Once again, let me say like 34 randomly, some random values, and I'll move my cursor here. Can you see I'm touching my run button and click once? You can see your code executes for a fraction of a second, process the data, and shows the output. You can see there is no change on the block diagram. You will not see any changes on the block diagram, but on the front panel you can see the data are moved to the block diagram, get accessed, get manipulated, and the output is being visible to the front panel again, right? So if I make any changes, let me say I want to make changes in the input. Once again, let me say I want to bring back the value to 24. You can see the output is not updated yet. The reason is we have to execute this application. I'll go here, I'll click on this button, so you can see the code is executed, right? So any changes I do, it is not updating it because I am supposed to run it, or I can go for run continuous. This is the necessity of a run continuous. So I click on run continuous, and any changes I do, you can see the grids are completely vanished, which means that the code is continuously running. Before, if you see when I was using run button, the code, the grid vanishes for a fraction of a second, the output is available, and that's it, it stops there. But run continuous, if you can closely see, the grids are vanished, and you can see the run button is like animated to be moving, and any changes I quickly make, you can see it is being updated, right? Any changes I make, it gets updated. So if I want to stop it, I personally don't recommend anybody to use abort function. Rather, you can click on the run continuous. So what happens is it stops immediately. The reason why I don't want you to use the abort function is, as I told you, LabVIEW is meant mostly for the hardware interface. It's not like it's only for hardware interface. There are many reasons why you use LabVIEW, but more dominantly we use it for hardware interface. When you use a hardware interface, what happens is, let me say you are controlling a motor, for example, or let me say you're controlling a boiler or turbine. So now what happens is when you abort an application, immediately, abruptly, the connection between your hardware interface, hardware and your computer or the LabVIEW where you're executing will abruptly get broken. So your hardware is left on the very last state which was being executing. So which is actually very bad habit in an industry. So what I have to do is, you're supposed to stop the code properly, make sure your hardware interface is properly terminated, not aborted. There's a huge difference between terminating and aborting. Aborting is an abrupt way of disconnecting anything, right? So I don't want anyone to start using abort. There are some time where your code doesn't respond, it gets into infinite loop, it gets into a deadlock. There, yeah, you have to use abort, but always try having a habit of using run continuous or use loops so that you can stop them, right? So if I want to delete any of this item here, if I want to delete any of the items here or here, what I have to do is, in front panel or block diagram, I'm simply supposed to click on them. You can see a dotted line showing it is being selected, or draw a window across it like this. You can see where any item inside that block was selected. I repeat it, select it and press delete button. Right? If you want to bring it back, press Ctrl Z. That is all. Okay. So for example, if I delete this, you can see some special item, something like a broken, wire. This is a broken wire. The reason why this wire is broken is it was before connecting a source and destination, maybe whatever it is, right? So it is connecting two items, but now one of the item is missing. So this wire is like now floating, right? You're supposed to remove this. You can see when you have a broken wire on your screen. When you have a broken wire on your screen, you can see your run button is broken. Your run button is broken. It means that you cannot execute your application. Your application has an error. So when I click on this, you can see it says that the wire has loosened, right? The wire has loosened, and I double click on this error. You can see that it clearly highlights me, there is my error. These are the predominant advantages of using LabVIEW. It has a very user-friendly type. So what I'll do is, either I'm supposed to create it. So what I'll do is I'll quickly create an indicator, drag and drop it. I'm naming it to be my sum. It can be any name, right? So I'll drag and drop it like this. Count it from here to here. Right? So now you can see I'll increase the size either. Now I can run this. You can see the output. Right? Fine. So I'll just move into a different demo. This is a very simple application. I'll just move into a different demo. Before going to a different demo, what I'll do is I'll also introduce something called as constants. These are variables. Basically what we are using is controls and indicator right now. So these are variables basically. But I want to even show you something called as constants. The major difference between a constant and a variable or a control basically is nothing but your variables can be changed during the runtime. What I mean by runtime is when the code is executing. When the code is now executing, it is in run continuous. I can change the values, am I right? I have the ability to change the values in the control, and you can see the indicators get automatically changed depending upon the control what you have been using, right? But there are also called as items called as constants, where you can set them before the execution and you cannot change when the execution starts. That's basically called as constant. They will not be changed during the runtime. And these constants are available only on the block diagram. I repeat, these constants are always available only on the block diagram. The reason is front panel is a user interface. When you allow or when you insert any item on the front panel, they are always accessible by your users. When you want constant to never be changed, you should leave it in the block diagram only. So what I'll do is I'm going to show you quickly how to create a constant. I'll right click on the block diagram, go to numeric palette because I want to create a constant of numeric data type. You can see there is a constant, right? DBL. DBL stands for double position numeric constant, right? There is also a blue color constant which is normally termed as a numeric constant. Finishing this demo, I'm going to tell you what is the difference between an orange color constant and a blue color constant, or whatever maybe they need not be a constant, basically a controller indicator. I'm going to show what is the difference between them, right? So I can drag and drop the item here, right? So I can say a value here. You can see that when I drag and drop a constant on my block diagram, there is no relevant terminals being created on the front panel. That is a specialty of your constants. Constants are always on your block diagram. They don't leave any hint on the front panel, right? So I'm going to randomly give a value. For example, let me say 120, right? It can be fractional values also. Even here, it can be a fractional values, right? I want to add, input A, input B, and this constant. What I can do is I'm going to take one more add function, drag and drop an add function like this, connect it from here to here, connect it from here to here. I'll remove this wire, select it and delete it. From here, I can connect it here. I can move wherever I want it. So now what happens is very simple. The value of 63 from input A passes here. The value of 49.6 will pass here. And the value constant 120.5 will pass here. You can see that these two inputs get added in this terminal. And the output of A plus B will go here and gets added with the constant. And the overall sum will be displayed here. Fine. So when I run this program, I'll run it once, or maybe I can go for run continuous also. You can see the data are being shown here, and any changes I'll be able to do on input A, input B is happening. But if I try changing my constant value, it never allows me to change the constant value during the runtime, right? It will never allow me to do the changes on the constant during the runtime. This is the advantage of a constant. We'll be using constant a lot time in this entire 5 days of courses. So I'll stop this, and I'm going to show you how to save this program also quickly, right? And if anybody is getting some doubt, something like there is a run button here on the front panel, there's a run button on the block diagram, which one I'm supposed to use, either this or that. Don't worry, it's for the developers, feasibility. They have given it in both the windows. You can either use this run button or that, but both runs together. When I click on the run button here, see, let me say I just change this value 123, run the code using the run button on the block diagram, you'll be able to see the update happening on the front panel, right? So they work together. When I say run, it's basically running the VI. When I say VI, it's together front panel and block diagram. So you don't want to worry much about which window I'm supposed to prefer to execute this application. It's okay. You can feel free to use both the run buttons, right? And to save it, yes, once again, you have a file here. You have a file on the block diagram also, right? So you can save it from any of the window. You can even save it from this window, not a problem. I'm going to say file, save, right? So I'm going to name it as, I'll name it as simple add, right? So I'm not making the extension. I told you in the beginning the extension will be .vi, and you can see it's automatically taking the extension .vi, right? I'll say OK. Yes, hope it's clear. I'll just move to the new VI. I'm going to show a difference between a normal orange color numeric control, or orange color indicator or constant, compared to the blue color item, right? So I'll drag and drop a numeric control, right? There is no big difference in the color on the front panel, but you can see that there is a color being displayed on the block diagram, right? Same wise, I drag and drop one more numeric control like this. Both are in orange color, right? So what I'm going to do is I'll right click on the numeric 2. I'm going to representation. I right click on numeric 2. I have list of options in which I'm going for representation. I'm going to say, for example, I32. I32 stands for integer 32 bit. You can select the bit representation of this number, the memory, how much it's supposed to allocate. You can choose it. I'm going to go for example, I32. So as soon as I change it to I32, you can closely see here on the block diagram. I'll just go zoom into the block diagram. I'm coming to the block diagram. You can see there are two controls. One is orange color and one is blue color. You can see it is written as DBL and on input number 1 and I32 on the input number 2, right? So basically a color difference of orange and blue basically represent whether they are a floating point data or an integer data. What I mean by that is, if I say a floating point, I can give a fractional number in my orange color controls. This is orange color control. Sorry, this is orange color control, right? This is orange color control. You can give a fractional data. But coming back here, if I try to give orange color, a fractional number, let me say 2 point, you can see it rounds off to the nearby integer. 8.98, it can see it rounds off. It doesn't allow you to give a fractional data. That's a basic difference between a orange color data type and a blue color data type, right? There are also further applications, like let me say, if I say Boolean, I drag and drop a Boolean item. You can see Booleans are basically green in color. For example, let me go for strings. I'll take a string control, right? You can see that it is basically orange, pink in color. So these are the basic data types. Usually your floating point numeric will be orange in color. Your integer numbers basically will be in your blue color, and your Booleans will be in your green color, and your strings will be in your pink color or a purple color, right? So these are common basic simple data types we use. Going further, we are also going to introduce more data types. So I don't want to stick more into the data types, whatever is available in LabVIEW, because it has an n number of data types, which I don't think I can finish it by today. So whenever needed, I'll try to introduce a new data type, and the colors related to that particular data type I'll be trying to tell you all. Fine. So I'm just directly jumping into a demo. If you want to see a demo, what I'll do is I'll just quickly design an application. Let me say I was showing Celsius to Fahrenheit conversion, something more similar to that, right? So what I'll do is I'll take a numeric control, for example. I'll take a numeric control. I'm going to name it as input temperature, right? I can name it as input temperature, or I can also name it as it is being mentioned in Celsius. C basically represents it's the Celsius data. I'm just giving a name as such, right? So whatever input I just passed, it's a Celsius information. I'm going to say, let me say 100 degrees Celsius is what is my input. I want to see the corresponding indicator in Fahrenheit. Let me say I want the output to be in Fahrenheit. I'll take a numeric indicator, right? I'll take a numeric indicator. I'm going to name it as Fahrenheit, right? This is my output is going to be. I'm going to see the Fahrenheit update. I'm going to do a simple conversion, temperature conversion from Celsius, whatever X value I say as a Celsius value. I want to see the corresponding Fahrenheit. Let me quickly do this application. So let me say the formula for this. The formula for your conversion of Celsius to Fahrenheit is, so your input multiplied with 1.8 plus 32. That is your formula. So I'll quickly take a multiply function. So multiply by your input with a constant 1.8. When I say 1.8, it's a constant. It's not going to vary, right? So I'm going to take a constant, drag and drop it. I'm going to name it as 1.8. Fine. So I directly connect it from here to here, right? So I'm going to take one more addition function, drag and drop it here, right? I'll connect it, the output I'm just counting here to the addition. And there's one more way to create a constant. I'm going to give a shortcut to create a constant. Just watch here. I'll touch this terminal where I want to create a constant. I'm going to create a constant of 32 in this terminal right now. I want to do that. So I'll right click on this terminal. Just watch. I'll right click on this terminal. You can see a list of options. I'm going to say create a constant. I'm going to name it as 32, right? So from here, I can connect it from here to here, right? Maybe people may come up with a question, a 32 can be an integer. Why are you making it in orange color, right? So what you're trying to say is this representation, I'll right click on this representation. I can make it I32. You might think this can be like this. Am I right? Why are you making this to be a, orange color? The reason is you can see that the connecting terminal point for this add function can have a red color dot when you try to connect in that fashion. The reason why it has a red color dot is very simple, that it's because you're trying to enforce a data conversion. See here, this input has one data type to be a orange one, output to be a orange one, but there's one odd one out here which is actually blue in color, right? So your data is being converted from your I32 into a DBL data. So that conversion, automatic conversion, is being coercited, right? So you can see there is a red color dot saying that it is a there's a data type conversion happening automatically. So basically this kind of data type conversion consumes more memory. The reason is the LabVIEW internally has to find what is a compatible data type it's supposed to be used, and it has to find out that convert this data type. Bit conversion should happen from this data type to the another data type, and basically it gets up converted. Okay, so it has to get converted to the DBL data type, double position data type, floating point data type, and then the output will be assessed, which is supposed not to be done. So the good practice is to use the same data type all over the entire application. Now you can see that your LabVIEW is not having a correction dot. The reason is you are using a very compatible data type. The name of that red dot is called as correction dot. Fine. So I'll close this. Now I'm going to test this code. So I'll run this program once. You can see it is showing 212. I'll just name it as 36 degree and run this. You can see this is the temperature. Fine. So this is how a simple application can be designed, or it can be any mathematical equation if you really want to solve it. It's up to you. Fine. So I'll just move quickly further into this applications. So I want to get started with the loop concept. Before that, I want to even show some quick example of Booleans also, because we'll be using more of Booleans in your loops. So I'll just go for Booleans, right? I'll take a Boolean control. Let this be a Boolean control. You can see that this is a Boolean control. When I talk about Boolean, it's nothing but it's like, high and low states. In LabVIEW, we call it as true and false. So this is in false states right now. So when I click on this, it turns into a true state, false state and true state, right? So you can, if you see numeric, you can have n number of values as an input. It can be any number, whereas here it is going to be either true or false. Fine. So I'm going to take one more input, right? This need not be always drag and drop. You can also select this, Control C copy, Control V paste, so that you can name them whatever you really wish, right? I've created two controls. I'm supposed to create an indicator. Now you can drag and drop a round LED, which is actually an indicator by default. What I mean is I can drag and drop a round LED like this, and I'm going to name it as output. Fine. I have a output. You can closely see the block diagram. I have two inputs, one output. How do you find it? It's input or output. The direction of the flow of data tells you whether it is a input or output, right? So A and B have a terminal facing outward, and you can see that the output is having terminal facing inward, right? So now what I'll do is I'll close this window. Now let me say you want to use the same kind of push button. I was using a push button for your input, right? I drag and drop a push button like this, and I'm going to name it as output, right? But the problem here is you can see my A and B are also having the terminals facing outward. You can see the output function, right? Even that is facing it outward. Basically it has to be facing inward, am I right? But by default you can see that the push button usually has a tendency to be a control, not an indicator. So in these cases what you have to do is just right click on a particular item on the block diagram. Just watch here. I'll right click on my output terminal and I'm going to say change to indicator. You can see now the connection terminal moves to the front side facing inward, right? So now we can see this is an indicator. These two are controls and this is the indicator. Now I'll just quickly go for a Boolean operation. Let me say I want to go for a AND gate, right? I quickly place the AND gate, directly connect it, right? Directly connect it from here to here, and I'll just make it run continuous. You can see low here, the output is low because we are doing AND. So low and high, still the output is low. High and low, still the output is low. High and high, you can see the output is high, right? So this is how a basic function, Boolean functions work like. Need not be this kind of application, simple, operators. Let me say I have a numeric data. I'm going to name it as a mark. For example, I'm just saying this is a mark secured by a particular student. Let me say, I'll just quickly show a demo on this also. And I'm going to say whether he has passed or failed with a Boolean button. I'm going to take a round LED if you wish. As I told you, round LEDs basically have the tendency by nature, by custom, that they are indicators. You can see the arrow mark facing inward. It is an indicator. So now let me say the pass mark is 40, right? So any mark less than 40 should be displayed as a fail. Any mark above 40 should be displayed as pass. Pass and fail. I want it to be in this way, right? So let me show you how to do this. So I'm going to name this as to be a status, right? So I'm going to go for comparison because I want to compare the mark with the pass mark, right? So I'm going to say, right, greater than or equal to. You can use anything, but I'm just going to use greater than or equal to. Drag and drop it here, cut it from here to here. This terminal where I want to create a constant. Why a constant? Because the pass mark is always constant. I'm not going to change it anyway. So right click, create constant. I'm going to say 40. That's my pass mark. If this condition satisfies, I want this Boolean to be switched on, right? So you can see mark compared with 40 and the status is going to come up here. So I'll run continuous. Basically it is 0 mark, so it says he is a fail, right? It's a fail. When I say 40, you'll be able to say it says it's pass. Even 39.9, we are using basically a orange color data, which means that there is no round off going to happen. So you can see it is fail, right? So this is how you can try using comparisons and do some thresholdings, with your LabVIEW applications, right? So what I'll do is we have kind of 10-15 minutes left out. So with this, I'm just finishing the section 1, right? I'm just trying to finish the section 1. I'll go to the slides. We are finishing the section 1. So the demo is over, section 1. I'll just move to the section 2 where we are trying to move into loop concept. We are going to understand what is loop in LabVIEW and how LabVIEW is going to handle the loops, right? If there's any doubt in the section 1 till now, whatever is being covered, if you have any queries, I want you to feel free to just, write it on the comment window. Right now, I have not, answered all the questions being asked, right? So I'll just try to finish the session. We hardly have 10-15 minutes left out. I'll just finish it because we started 5-10 minutes late. I want to make sure that I'll use the time also. So I'll finish that and I'll move to the queries section, right? So coming back to loops in LabVIEW, basically you would have used loops in your C program. Basically, most of the people who are being using programming language who's interested to attend the session might have used. I'm not saying you have used. Might have used LabVIEW. C program where you would have come across loops where you have 3 different types of loops. You basically name them as a for loop, do while, right? These are different 3 types you have. But LabVIEW has only 2 different types of loops, right? LabVIEW has only 2 types of loops, not 3 types of loops, namely a for loop and a while loop. I repeat it, a for loop and a while loop is what we have in LabVIEW. A for loop in LabVIEW is exactly same to your C programs for loop. Anyway, I'll just get into it. I'll just quickly explain that and show a demo to you. And coming back to your while loop, it's slightly different. Your while loop in LabVIEW behaves like a do while. I repeat, a while loop in LabVIEW behaves like a do while. Okay, so if you're not sure how is a do while is going to work, I'm going to anyway to explain you how this while loop is going to work in LabVIEW also, right? So first, moving into while loop, basically what happens is it has a code to execute. I'm just showing the pseudocode of an basic while loop, how it executes. So it has a code. It keeps repeating the code. That's the need of a loop. You are using a loop only for that purpose. You want to execute a certain code continuously, right? So I use a while loop, for example. That particular code you want to execute, it's going to get repeatedly executing. So till how much time? Until the condition satisfies, right? Until the condition satisfies. But here comes the difference between a while loop and a do while in C program. In a C program, if you notice, a while loop basically checks the condition. I repeat it, in while loop it checks the condition, then goes for execution, whereas a do while will execute and then check the condition. Am I right? In LabVIEW, while loop behaves like a do while. What it means is it executes the code once, then goes check. Execute the code once, go check it again. Execute it again, check it again. It keeps going. When the condition satisfies, there is a condition to be checked always, right? When the condition satisfies, it ends. That's how it basically works. In LabVIEW, this is how a while loop looks like. You can see there is a while loop, which is like a broad frame. You can see there's like a frame in which you can design your code into it. You can paste your code into this. And you have a condition. Can you see there's a Boolean control? A green color means Boolean, am I right? Which means it's nothing but a condition. So you have a condition terminal in which you can connect your true or false. A true means the condition is satisfied. False means the condition is not satisfied. How it executes it? It executes this code once, check the condition. Execute the code once, check the condition. Execute once, check it again. In any point of time, if the condition is met, which means that if any point of time it is true, the code stops immediately. It will never go for another execution. Fine. So this is how a while loop basically works. Coming back to a for loop. For loop is more similar to the way how we've been using in your C program. So you specify an n value. N value is nothing but the number of times the loop is supposed to execute. It's a finite execution where you decide how many times the loop is going to execute in advance, right? So I'm going to say I want my loop to execute for 100 times. Here we have something called as I. I stands for iteration. In the iteration, you're initializing to be 0. And you can see that iteration keeps on incrementing. I keeps on incrementing. And you can see until I reaches n value. Starting from 0 unless it reaches n value, the code keeps on repeating. The code is repeated. Also, I is incremented by 1. So what happens is, in the beginning, I starts with 0. Right? N will be always 100. It never changes. Okay. So n will be 100. I starts with 0. then 1, then 2, then 3, then 4. It keeps on increasing till n value, which means that till it reaches 100, it keeps on executing. The particular code is supposed to be executing. Coming back to, for loop in LabVIEW, you can see there is a blue color number. This is an example where I'm just specified 100, right? So a blue color means it is a integer. Blue color means it is an integer. The reason why it is not a floating point is I can't say a loop to run for 4.3 times, 5.10 times, 5.9 times. It's not possible. So what I say is it's going to be 100. Okay, it can be a integer value, right? So when you say 100, any code paste inside this is going to execute for 100 times. That's how a simple loop basically works like. I'm going to quickly get you into a demo session with this, right? So I'm going to show first, let me start with for loop. Okay, I'll right click on the block diagram. You can see structures. And there are n number of frames you can see, structures you can see. I have a for loop in the first and while loop in the second. Let me first start with a for loop. Just watch everyone closely. I'm going to drag and drop a for loop like this, right? So this is a for loop. I'll just give a label to it, visible item, label. This is a for loop. Maybe if you want to see the comparison how a while loop basically looks like, I'll take a while loop, not an issue. I'll just drag and drop a while loop like this. This is a for loop and this is a while loop, right? Visible item, label. This is how a while loop looks. I want to see both together in the same frame. So one common terminal between a for loop and while loop is iteration. You can see iteration is a common terminal for loop and while loop. In LabVIEW, you don't want to program I value to increment step by step. It happens automatically. I repeat, you don't have to configure your I terminal in LabVIEW. It happens automatically. First time the loop runs, the I value will be 0. Whatever value comes from here will be 0. Next time it turns into 1, next time it turns into 2, and keeps on going and keeps on incrementing till it reaches the n value. Right? Basically, since I value starts with 0, right? First iteration the value will be 0, second iteration will be 1, third iteration will be 2. And now, for example, if I configure, right click on n terminal, create constant, I configure this loop to run for 10 times, for example. So first iteration it will be 0, second iteration 1, 2, 3, 4, it keeps on going. So at the 10th time the loop iterates, the value will be 9 and the loop stops here, which means that the I'll write it here, the I value, right? It will start from 0 to n minus 1, right? So I value will be 0 to n minus 1 always. This is a comment window. There's nowhere I'm writing a program. This is not a program. It's just a comment. Free label comment I'm trying to make here to make you people understand. So I value starts with 0 and goes till n minus 1. Why n minus 1? The reason is the loop iterates for n times. So since the iteration terminal is placed inside the loop, the I terminal also will iterate for n times. Starting from 0, 1, 2, 3, 4, 5, 6, it goes till 9. Ultimately, it would have taken 10 different values, right? Same holds good for your while loop. But one difference in while loop is we will not be judging the while loop in advance how many times it's supposed to execute. It's not possible. The reason is here in for loop we are controlling it using a number, whereas here we are controlling using a different data type. It's nothing but your Boolean. It's your condition. When I touch this, you can see it's a loop condition terminal, right? It's loop condition terminal. I can right click on this and create a control, right? Many people try having a demo. Now what they do is they create a constant. See, when you create a constant in while loop, what happens is a constant can never change during the runtime. Am I right? So now if I try executing this program, you will not be able to stop this while loop because the while loop basically stops based on this condition, right? So what happens is when the constant starts executing, it can never be changed. So what happens is during the execution of your program, you can never change this constant value. You can never convert this to be a true like this. Now I'm converting it because it's in a edit mode, not a run mode. So what happens is it cannot change from false to true. So what happens is the condition will never satisfy. A true means condition satisfy and false means condition not satisfy, right? So for that purpose, at least I'm not going to create a constant. I'm going to create a control, right? So when I create a control, I told you when you create a control or indicator, you'll have a relevant terminal on the front panel. And when you create it on the front panel, you see a terminal on the block diagram. When you do it on block diagram, you see it on the front panel, right? So now what happens is the while loop, it will be uncertain how many times it is going to execute. So now when I start running this program, just watch here. When I start running this program, I'm not running continuous. That's very important. I'm not running continuous. I'm going to run only once. Before, if you see, when I run once, the code executes for a fraction of a second and stops immediately, whereas now it is not happening. The reason why is I have been using a while loop, which tends to keep executing a certain code many times. I mean, here for demo purpose, I have not used any code placed inside any of these loops. But in a real case of usage of this for loop and while loop, you'll paste some code inside this loops, right? So here you can see why basically this stop button is in false mode, like how we saw, a push button, right? It's more similar to that, but the representation, the physical representation is totally different here. So when I click on stop, what happens is it turns true and the loop stops. Before it was in false. So what happens is the condition was false, right? The value false was passing in the loop, while loop. So that loop tends to keep executing many times, right? So the moment when I click on the stop button, what happens is when I click on this, you can see it is being pressed right now. So the value of true passes here and the loop immediately feels it, the condition is satisfied and stops. This need not be always a button. It can be comparison like what I did last time. I was having a numerical value. I was comparing whether it is reaching 40 or above 40. Then I stop it. Now it can be based on a condition. In real time, how we do it is we have, let me say you want to do a closed loop system where you have a boiler being, you are trying to power up a boiler. Okay, you're trying to power up a boiler and you have a pressure sensor. This pressure sensor is going to monitor the boiler's pressure inside, the pressure sensor is going to measure it, and you want to do a system in such a way when the pressure goes above some 1 bar, you want to shut down the wall, which is lighting up the the heating up the, just a second, okay, so it stops heating up the boiler, right? So you can design an application something like that. So very simple, what you do is you can put a sensor data here. Rather than this, you will have a sensor data. You can acquire the sensor data with the hardware interface, and then you can compare it with the threshold where the bar value tree rises, and then you can stop, right? So you can do that. So what I'm going to do is I'm going to quickly show a demo with the while loop. Let me start with the while loop because we are running out of time. I'll just try to finish it within 5 minutes because we are done. Right. Anyway, the examples related to for loop and while loop, and there are some more things like shift registers are related to for loops and while loop, which I want to show, which is anyway not a part of today's plan. So tomorrow we will be starting with shift registers and we'll be moving on to a different topic, right? Fine. So what I'll do is I'm going to create a control, which is nothing but a stop button, right? So for your demo purpose, what I'm going to do is I'm going to create one set of code, control copy. Right, I'll just copy and paste a control and one more indicator, right? I'll paste it like this. I'm going to name A, I'm going to name B, and this one I'm going to name it as C, right? And I'm going to take a numeric add function, right? Count it like this. You can see this certain set of code is kept inside the while loop. Am I right? This particular code is kept inside the while loop. What I'm going to do is I'm going to copy paste, just C, select this, Control C, Control V. I'm pasting one item outside the while loop, and you can see that this particular set of code which are kept outside the while loop is A2, B2 and C2, whereas the one which is kept inside is A, B and C, right? I'm going to show you how this is going to work, how this is going to make difference in their code while placing inside and while placing outside. I'm going to show you, right? So what I'll do is I'm going to write 100 here, 12 here for example, and for example 23 here and 45. You can closely see that my C is not updated, my C2 is also not updated. The specific reason why it is not updating is I have not executed the code now, right? Just closely watch. The moment when I click on run once, just notice when I click run once, you'll see your C is also updated, your C2 will also be updated. This will get updated, this will also get updated without any issue. Watch here, I'll run it. You can see both gets updated with the specific value. 100 plus 12 is going to be 112. 23 plus 45 is going to be 68. Both are getting updated. Okay, but very importantly, since this particular set A, B and C is kept inside the while loop, you can see it is iterating it many times. A loop is supposed to be used for this purpose only, right? So any changes I make, you can see any changes I make on A or B, it is replicating on my C. But same as that, any changes I make on A2 or B2 will not replicate on C2. The specific reason is you ask the code to run once. A code which is not enclosed on the loop will execute once, and it has already executed once and gave you the output 68 and you stopped. Whereas coming back to the other code like A, B and C, even though you asked it to run once, the loop is running many times. Loop has the ability to run many times a code which is being placed inside it, right? So you can see the code is being executed many times, and how much time it's going to execute? Until the condition satisfies. What is the condition here? A stop button is a condition here for this loop. When I click stop, the loop stops, and now you can see any changes on A or B will not replicate on C, right? So any changes on A or B will not replicate on C. If you ask me what is the difference between a run continuous and using a while loop, I can programmatically allow my loop to stop. What I mean is, just watch here, right? I don't want this stop button. I'll remove the stop button. I'm gonna use comparison. For example, I'm gonna say when the value is greater than or equal to, I did this before, am I right? And I create a constant, the added value, the C value, I'm just trying to compare it. I'm gonna say 1000. This is what I'm trying to tell you, and I'll just connect this directly here, right? So now what happens is pretty simple. You can see A value, let me say I'm going to say A value is 200, B value is for example 400, the output is going to be 600 anyway, right? This 200 will pass here, this 400 will pass here, get added, the output of 600 will go here, and also you are comparing that value with 1000, right? So any point of time when I keep changing the value, the summed up value goes above 1000, you'll see that code automatically stops. Fine. And also, meanwhile, yeah, this guy who's kept outside, right? This certain code which is kept outside, right? Let me give some random value to this guy also. So any values I give, when I run it once, you'll be able to see that both the codes executed, they were giving the output. Similarly, like last demo, you can see any changes on A2 and B2 will not, affect C2 because they have already finished this execution. Coming back to A and B, you can see any changes are replicating without any problem, right? Without any problem. And how much time is going to do? This time it's going to be a condition. Just watch here. If I say 500 here, you can see 929 is the summed up value I've reached. So if I go further, you can see that when I go further, still it is executing. The moment, let me say I just say 510 and click outside. No, it is not updated yet. When I click outside, you can see the output is being shown here. Immediately you can see that 500 is passed from A, 510 is being passed from B, get added up, and the output of 1010 is being displayed on your C. That is happening. You can see 1010 is being displayed, and it's also parallelly being compared. 1010 is compared with 1000, and comparison wise, it understands yes, it's true, and it's stopping the loop, right? So this is how an automation system can be basically. This is a simple automation where you can do with a switching on and off, right? So this is how people can use it. This cannot be achieved with your run continuous. Run continuous basically allows, run a program till anybody wants to run, and if they want to stop it, they should use abort or run continuous again, it will stop, right? So whereas a programmatical stop or programmatical condition satisfaction can be done using your while loop. Clear? Yes. So this is how a while loop runs. This is the basic architecture of a while loop. Moving further, I will also show you a for loop. Usually for loop, the problem is, you're supposed to say how many times the loop is supposed to run, right? This is not a problem. I'll tell you what is the constraint you have this. I'll just tell you. So I'm going to say my loop to run for 100 times, right? And any code you place inside, just watch here. I'll try to use add function. I'm going to do same application, right? I'll copy paste. Name them as A, name them as B, sorry. right? So then I need a indicator. I'm going to enter C. I'll move it here. I'm supposed to keep them all inside the loop. Don't keep it outside the loop. Anything enclosed inside the loop will iterate many times. If you keep it outside, they execute only once. So don't do it. Okay, so don't do it. What I'll do is I'll quickly connect it from here to here. I'll connect it from here to here. I'll also connect it from here to here. The simple connection what we usually make, right? Okay. So what I'll do is I'm gonna give some values, right? Sorry, 120. I'll give some values, right? So when I run it, just watch here. When I run it, you can see, just notice, I'll explain you what's happening. Maybe it's quite complex to understand what's happening. Just watch here. So I'll just say, I want this to, I want the value to be 100 here, 120 here, but the output is right. 100 plus 120 is 220. It is basically right? But the problem is, you want this code to run for 100 times, but you can see when I click on run once, it goes in a fraction. Like a normal run without a loop. You can see that it runs once, gives the output once, and it stops. But ultimately what you want the for loop to do, you want it to be iterating it 100 times, am I right? So just watch here, when I click on run button, it is not actually happening. Actually speaking, it's happening, but it looks in the naked eye that it is not happening. For this purpose, to understand this entire scenario, what is happening, it might be a bit confusing now. I'll tell you what is happening, how it's basically working. I have iteration, right? Now this iteration is going to help me to understand how this particular code is basically working. So what I'll do is I'll right click on this iteration, create an indicator. I'm going to create an indicator. Okay, so I'm creating an indicator for the iteration. I told you how iteration works. First time when the loop runs, it shows 0. Second time it runs, it shows 1. Third time it runs, it shows 2. And it keeps on going. And what will be the last value? It will be n minus 1. When the loop is iterating for the 100th time, the I value will be representing 99 and it stops there. That is how this loop is supposed to, iteration terminal is supposed to work like, right? So just watch here, just closely watch. When I run this once, I'll initialize this to 0 again. Just watch here. How it's supposed to run? 0, iteration should show me 0, 1, 2, 3, 4, 5, 6, 7. It has to keep on going till 99. But when I run this once, you'll be able to see directly it jumps to 99, right? The problem here is the loop is too fast. It's very fast that actually the iteration value started from 0, 1, 2, 3, 4, 5. It went till 99, but it was too quick that you are unable to see any of the intermediate values, right? So to make you people understand how this works, I'm gonna make this highlight execution. Come to the block diagram. You can see run continuous, abort, pause, and now I'm going to say highlight execution. What does a highlight execution do? It's very simple. It slows down your application and show you how the data are flowing and how it's being working. It just shows the animated version of your program's execution, right? So now what I'm going to do is just keep it here, and for demo purpose I'm going to name it 10 because highlight execution is too small that it takes a lot of time to finish 100 counts, right? So I'm just making 10 for demo purpose. Just watch now closely. When I run this program, you can see the data. Look at the block diagram. You can see the data are flowing, right? The data are flowing. You can see I value is 3, 4, 5. It is actually working slow now, right? So once it reaches 8, 9, you can see the loop stops automatically. I'm not doing anything, right? I'm not doing anything. The loop stops automatically. If I say this to be 15, right? If I ask the loop to iterate for 15 times, any code inside that will iterate for 15 times, and now it is a slow highlighted execution. Now you can see the iteration is taking all the value as I told you, 0, 1, 2, 3. It goes till n minus 1. N minus 1 is nothing but your 14. The moment it reaches 14, meanwhile any changes I do here, yes, it will update. I made it into 123. The output of 123 plus 100 is going to be 223. You can see it is happening. So any code is iterating many times. You can see the data are flowing, getting added up and updating the indicator. Once it reaches 14, you can see it stops automatically. When you see the same thing without a highlight execution, I repeat, when you see the same thing without a highlight execution, I'm removing the highlight execution. When I run it, just watch. I'll make it 0, reinitialize, and run this once again. You'll be able to see that I'll just stop it, right? So it automatically stops at 14. I'm just running it. It is stopping at 14. Hope you can understand this, right? So I'm just stopping the session for now, so that we'll get back to the session tomorrow, and we'll also mention you what is the agenda tomorrow in the same link. We'll just tell you what is the agenda. You can just log into the live stream tomorrow also. So if you have any queries, I'll try to address the queries, right? So even later point of time, you can watch this video in the offline. You can watch this video offline, and you can just try to come up with many queries, and you can paste the queries on the same comment section, so that we're gonna answer you the queries, right? Now what I'm gonna do is I'm gonna terminate this live streaming. I'm gonna terminate the live streaming, and I'll answer all your queries in the comment section, right? So if there is any queries, you people can write it. If you want me to address it, yeah, I can address it, not an issue, right? So I'll just minimize all these LabVIEW programs. So I'll just try to go for the comment sections, right? Okay, I can see people saying thank you. Sonali Rawat has told thank you. Thank you all for showing interest on LabVIEW. So tomorrow we'll be getting into deep concepts, and we'll be trying to work on much more complex applications. And we are also planning to come up with some toolkits and show some demos on some toolkits, right? So depending upon the time allocation and the interest of the people, we are planning the upcoming sessions, right? So regarding the agenda of tomorrow's session, we'll be trying to ping you tomorrow. You can come and check tomorrow's link on this video. Whatever video you saw now, you'll be able to see the informations here, right? Thank you so much, everyone. Have a nice day. Stay home, stay safe, and let's learn together. All the very best. Thank you so much.